All right, let's jump right in. Today, we're diving into some really fascinating research from a PhD thesis by Valeriy Manokhin. It's all about something called probabilistic prediction, and it tackles one of the biggest, most important questions in AI today. How can we actually trust what an AI is telling us?
You know, it's funny, Mark Twain absolutely nailed it more than 100 years ago. Prediction has always been a risky business. I mean, think about it. For all of history, a bad prophecy could have massive consequences, whether you're an ancient king listening to an oracle or a modern trader watching the stock market.
And fast forward to today, our oracles look a little different. They're not sitting in temples, they're running on servers. We've swapped them out for algorithms, for artificial intelligence, and these new prophecies, they're shaping our entire world, from what a doctor diagnoses to how a self-driving car behaves on the road.
And that brings us to the absolute heart of the issue we're exploring today. What are the stakes when one of these AIs, a system we designed to be incredibly smart, isn't just wrong, but it's dangerously overconfident about it? I mean, 100% certain and 100% wrong.
So to even start to fix this, we need to completely change how we think about what a prediction even is. We have to move past simple black and white answers and start talking about the language of probabilities. So what's the real difference? Well, a simple point prediction is just a single answer. Think of an AI looking at a photo and just saying, "That's a cat." End of story. But a probabilistic prediction is so much more useful. It's the AI saying, "Okay, I'm about 95% sure this is a cat, but there's a 4% chance it could be a dog, and maybe a 1% chance it's something else entirely." It's actually telling us how uncertain it is. And the ultimate goal here, really the holy grail, is something called perfect calibration. This just means the AI's confidence perfectly matches up with reality. So if your weather app says there's a 70% chance of rain, you'd want it to actually rain on exactly 7 out of every 10 of those days. That's a system you can really begin to trust. But, and this is a huge but, here's the problem. Right now, many of the most advanced, most powerful AI models we rely on are smack in the middle of what you could call a calibration crisis. And look, this is not just some abstract academic issue. The research points out that these badly calibrated AIs are being used in some incredibly high-stakes areas. We're talking personalized medicine, self-driving cars, financial markets, even trying to forecast the next pandemic. In fields like these, being confidently wrong isn't just a simple mistake. It can be an absolute catastrophe.
So here's the really wild paradox at the center of all this. It turns out that as we make our AI models bigger and better at getting the right classification, they can actually get worse at knowing their own limits. Their confidence just completely detaches from their actual accuracy.
So, how in the world do we fix that? This is where the thesis introduces a really powerful solution, a framework for making predictions that actually come with a mathematical guarantee that they're trustworthy. It's a method called conformal prediction, and the core idea behind it is brilliantly simple. Instead of just blindly trusting what the AI spits out, it makes the model look back at its own track record. It learns from its past mistakes to give a much more honest and realistic level of confidence for its very next prediction. So how does this work in practice? Well, instead of giving you one single, potentially wrong answer, it gives you a range of possible answers. It looks at a new piece of data and asks, how much does this look like stuff I've seen before? Then, based on that, it creates what's called a prediction set, a small group of possible labels. And here's the magic. It gives you a mathematical guarantee that the true answer is in that set, say 95% of the time. It's a guarantee. Now, when you put this up against the older classical methods, you really see the advantage. Traditional techniques often have to make these big, risky assumptions about the data. It's kind of like building a house on a shaky foundation. But the methods from this research don't need those assumptions. They provide that solid mathematical guarantee, which makes them so much more robust and trustworthy. So, let's zoom out. What does this all really mean for the future of AI? Well, it's about a fundamental shift in how we build and, maybe more importantly, how we interact with artificial intelligence. A quote from Stanford professor Emmanuel Condé's that's highlighted in the thesis just gets to the absolute heart of it. The goal isn't just to build smarter AI, it's to build more honest AI. You know, an AI that actually knows what it doesn't know is infinitely more useful and way safer than one that just fakes it with false confidence. And this brings us right back to where we started. Whether it's a doctor relying on an AI's diagnostic suggestion or all of us trusting a self-driving car to see a pedestrian in the road, that trust has to be earned. It can't just be a leap of faith. And methods like conformal prediction are exactly how we build that trust on a real mathematical foundation. So I want to leave you with this one final thought. We're now creating the tools to make AI confess its own uncertainty.
The technology is getting there. The next great challenge, though, isn't going to be technical. It's going to be human. For a medical diagnosis, for a financial decision, for our justice system, what level of guaranteed confidence will we, as a society, decide is good enough? That's the conversation we all need to start having.